If Planet 9 refuses to shine, maybe we can catch it in the act of casting a shadow. While most detection methods rely on capturing light from a distant object, there's another approach, one so precise, so elegant, that it can reveal worlds hidden even from the most powerful telescopes. It's called stellar occultation. The concept is beautifully simple. When a celestial object passes in front of a background star, it momentarily blocks its light, causing a brief dip in brightness. Even if the object itself is invisible, too faint, too cold, too distant, its shadow still tells a story. For decades, astronomers have used this technique to study asteroids, moons, and Kuiper Belt objects. From these fleeting eclipses, they've measured sizes, shapes, and even detected thin atmospheres around icy bodies billions of kilometers away. But using this method to detect Planet 9 would be a different kind of challenge. First, the timing must be perfect. The occultation might last only a few seconds, and the alignment has to be nearly exact. You need to know the precise position of background stars, a reliable estimate of Planet 9's potential orbit, the expected path of the object relative to Earth, if and only if that orbit intersects with the line of sight to a background star, and we're watching at just the right time, we may catch that brief blink, a tiny star that vanishes for a heartbeat and returns. But here's what makes stellar occultation so powerful. It doesn't depend on the object emitting or reflecting light. It only depends on the fact that it's there, physically blocking photons from reaching us. It's one of the only tools in astronomy where darkness reveals truth. Planning for these events requires months of calculations, international coordination, and sometimes even airborne or remote observatories stationed in the predicted shadow path. Scientists have flown high-altitude planes into the occultation zone just to capture a few seconds of data. Imagine doing that for a planet we've never even seen. But if Planet 9 exists and its orbit can be narrowed down enough, stellar occultation might be the key to confirming it. Even a partial detection, a star dimming briefly and returning, could be the first concrete evidence that the object is real. And if we measure the duration of the occultation, we can estimate Planet 9's size, speed, and even density. If multiple events are observed, it's not just detection, it's a blueprint. Yet for all its promise, this method is also fragile. One cloudy night, one telescope malfunction, one bad prediction, and the opportunity vanishes. The next chance could be years away. That's why preparation matters, and that's why collaborations between professional and amateur astronomers around the world are vital. Some of the most successful occultation observations have involved small, ground-based telescopes operated by citizen scientists. In fact, you don't need Hubble to catch a shadow. All you need is timing, patience, and precision. And maybe, just maybe, the next time a star blinks for a second longer than expected, it won't be random. It'll be Planet 9, casting its silhouette across the stars, whispering, "I'm here."